Have you ever really wondered what's going on inside an AI's so-called mind? Well, let's forget all the sci-fi magic for a minute, because at its core, artificial intelligence isn't about creating a person. It's about creating one of the most powerful problem-solving tools humanity has ever conceived. So let's pull back the curtain and deconstruct how it actually gets the job done.
Which brings us to the big question, right? How does a computer go from just, running lines of code to actually thinking? How does it learn to tackle a problem all on its own? That's the puzzle we're going to piece together today.
All right, so to get to the answer, we first have to figure out what we're even asking the AI to do. It all kicks off with defining the kinds of problems we're trying to solve, and those are fundamentally human problems.
I mean, if you look at the textbook definition, it's actually pretty straightforward. We're not talking about building a soul or creating consciousness. Nope, it's simply about building systems that can do stuff that would normally take a human brain to figure out. It's all about capability, not personality.
And what kind of stuff are we talking about? Well, things like understanding what I'm saying right now, spotting tiny patterns in huge piles of data, learning from its mistakes, and of course, making decisions. But I want you to look at that very first one, problem solving. That right there, that's the foundation for pretty much everything else on this list.
So, if you want to teach an AI to, say, solve climate change, where do you possibly start? Well, you don't just throw it into the deep end. Just like a person learning a new skill, an AI has to start small. It starts with what developers call toy problems.
And you can see the difference is pretty stark. Toy problems are the practice field. They're simple, they're controlled, the rules are crystal clear. Real-world problems, on the other hand, they're the opposite. They're messy, they're complex, they're loaded with unpredictable data. An AI has to absolutely master the toy problems before it has any shot at tackling the real ones.
Think about a game of tic-tac-toe. It's a perfect toy problem. The goal is obvious, the rules couldn't be simpler, and there's a finite number of moves. This is the training ground. This is where an AI learns the absolute basics of strategy, analyzing its options and trying to predict what's going to happen next.
And once it's got tic-tac-toe down, the AI can graduate to something a little trickier, like this 8 puzzle. See, the environment is still controlled, but now it has to level up. It has to develop more advanced techniques to search for the absolute best sequence of moves to solve the puzzle.
Okay, so the AI has its practice puzzle. Now what? It doesn't just start moving pieces around randomly. No way. It needs a master plan. And this is where we get into the actual logic of how an AI thinks its way through a problem.
And this is so important to remember. It's not magic, it's a method. Before an AI makes a single move, it has to formulate the problem. That means breaking it down into clear, logical pieces that a computer can actually understand and work with.
And this is basically its internal checklist. It asks itself, 1, what's my goal? 2, where am I starting from? 3, what are all the possible moves I can make? 4, what happens to the puzzle every time I make one of those moves? 5, how will I know for sure when I've actually won? And finally, 6, what's the most efficient, the cheapest way to get there? By answering these 6 questions, the AI creates a perfect map of the entire problem.
So, once that map is laid out, the real work can begin. The AI has to find the absolute best path from the starting point to the goal. This whole phase is all about the search for a solution.
At the heart of this entire process are things called search algorithms. You can think of them as the engine that drives the AI forward. These are the specific techniques it uses to explore all those possible paths it mapped out, constantly hunting for the very best one. They're the backbone of so many AI applications.
But here's the thing, not all searches are created equal. Not even close. Over here on the left, you've got what's called a blind search. This is like walking into a giant maze and just trying every single path until you stumble your way out. I mean, it'll work eventually, but it's incredibly inefficient. But on the right, you have an informed search, which is so much smarter. It uses clues to make educated guesses about which path is the most likely to lead to the exit.
And what is that clue? It has a special name, a heuristic. A heuristic is basically just a rule of thumb, a shortcut, an educated guess. You could almost call it the AI's intuition. It's the secret sauce that lets an AI zero in on the promising paths and just ignore all the dead ends, which means it finds the solution dramatically faster.
Okay, so we've seen how an AI learns on these simple little puzzles and how it uses smart searches to find answers. But how does any of this connect to the real world? Let's bring it all home.
Well, the exact same logic applies. It's just happening on a massive, massive scale. Think about it. A self-driving car searching for the fastest, safest route,
That's a search algorithm. A medical AI scanning through patient data to find patterns that signal a disease, it's searching for a goal. Even when you talk to your phone's voice assistant, it's searching for the correct interpretation of your command. It's all built on these same fundamental ideas.
So here's the big takeaway. Whether we're talking about a simple 8 puzzle or a massively complex global problem, the core process is exactly the same. You define a goal, you map out all the possibilities, and then you intelligently search for the best path forward. That simple idea is the engine powering the AI that's already all around us. Now, this systematic approach is incredibly powerful for finding the best route in traffic or winning a game of chess, so it really makes you wonder, what happens when we apply that very same focused power to humanity's biggest puzzles? I'm talking about things like curing diseases or solving climate change. What then? That's something to think about.